Welcome to 8-2. Please remember to do all of the quick checks, check your answers, and complete any post-video checks that you may have, and ask questions if you're not understanding something. Here we're looking at 8-2, which is scientific notation and writing numbers in standard notation. Scientific notation, for the most part, is a way to write a really big number or a really small number using its powers of 10 to help show that, and kind of we get lazy. We don't want to write all of those zeros. So it's a condensed way of writing numbers. With scientific notation, you always have a number that's between 1 and 10, okay? It has to be less than 10, so it's only one digit in front of the decimal place, and then you're multiplying that by 10 to a power, okay? So here are some examples. So we've got 3.4 times 10 to the 6th, 5.43 times 10 to the 13th, and 2.1 times 10 to the negative 10th. So we can have negative powers, and that's going to show us really small numbers. Positive powers of 10, big numbers, negative powers, little numbers. So if we look at example 1, we've got 3 numbers here, and if we look at A, 0.46 times 10 to the 4th. Is this written in scientific notation? If we look back at our example here, we need to have one number in front of the decimal place. So example A is not written in proper scientific notation. We would need one number to be in front of that decimal place, not a 0, and it's one non-zero number in front of that decimal place. With B, we have one number in front of the decimal place, and then it's times 10 to a power. So this is written in correct scientific notation. With C, again, this is not, because we've got 2 numbers that are non-zero numbers in front of that decimal place there. So this is going to be not proper scientific notation. So in order to write a number in scientific notation, you need to first figure out where you're going to place that decimal. So if we look at this number right here, right now, 234,000,000. Our decimal place is right here. We need that decimal place to be moved so that we only have one non-zero number in front of that decimal place. So we want to place that decimal place between the 2 and the 3. So now we have to ask ourselves, well, how many spaces did I have to move that to get that decimal place where I want it between the 2 and the 3? And if you count the spaces, you had to move it 1, 2, 3, 4, 5, 6, 7, 8. So that 8 then becomes our power of 10. The same is true for small numbers. Again, here's our decimal place. We need to move it between the 6 and the 3 in order to have one non-zero number in front of that decimal place. So in scientific notation, that becomes 6.3. And we had to move our decimal place. Again, we had to move it 1, 2, 3, 4, 5 spots. However, when we move it that direction, because it's a small number, it's a negative power. And we will talk about why negative powers are what small numbers here in our next lesson. So here we have the answers to the quick checks. Go ahead and pause this, and when you're done, check it. We're going to look at example 3 now. So here in example 3, we want to take our number that's written in scientific notation, okay, and we want to write it in standard notation, which is normal numbers for those of you. So 8.8 times 10 to the 4th. So we know that's a big number because we've got a positive exponent. So we need to move this decimal 4 spaces. So remember, here's the decimal in scientific notation. We need to move our decimal place 4 spaces to make this number look big. 1, 2, 3, 4. So we are going to place our decimal place right there, and we get 88,000. If you were to punch this in your calculator, 10 to the 4th is 10,000. So 10,000 times 8.8 gives you that 88,000. So just kind of think about it as almost a big multiplication problem. Now, with a small number with a negative exponent, we're going to do the same thing except the reverse. We're going to move our decimal place to the left instead of the right. So again, we can see here our decimal was right here between the 7 and the 3. I need to move it 5 spaces because that's my power, and I'm going to move it to the left. 1, 2, 3, 4, 5. So I'm going to place my decimal right there. So I have 0.000073. Go ahead and give it a try, the 2 quick checks below, and then don't forget to check your answers. So here we are trying to compare 4 numbers in different forms, and they have some powers. So the first thing you want to do when you're trying to compare numbers, which one's the biggest, which one's the least, is you want to write them all in scientific notation. Now the beauty of this is if we have them in scientific notation, we can then arrange them by the least power to the greatest power. So as we start to rearrange them, we have our least one, which is 2, and then our 3 power. And now we have these last 2 here that we want to compare. If you were just comparing 6.03 or 6.31, which one's smaller? 6.03. Okay, so that's all you have to do with comparing scientific notation numbers, is write them all in scientific notation properly, look at their powers, and go from there. The smaller the number, or the smaller the power of 10, the smaller the value. Now with multiplying scientific notation, I want you to think to yourself, 2 times 3 times 4. What is that? That's 24, right? So does it matter whether you multiply the 2 times the 3 or the 3 times the 4 first and then multiply it by the 2? Order doesn't matter. And we have a property. Can you think of the name of the property that allows us to multiply 3 numbers in any order? Let's see if you get it. It's the associative property. So using the associative property, you can multiply in any order as long as you're just multiplying. So if we look at example here, A, we've got 6 times 8 times 10 to the negative 4. So when I'm multiplying numbers by scientific notation, I like to multiply my whole numbers together and then multiply my base. The same here. 0.3 times 1.3 times 10 to the third. So I can multiply those, and most of you can multiply that in your head, and you get 48, right? Times 10 to the negative 4. Now, 48 times 10 to the negative 4 is not proper scientific notation, so we have to move that decimal place 1 place to the left and add a power there, and we get 4.8 times 10 to the negative third. Here we get 3.3 times 1.3, which gives us 3.9. Excuse me, that gives us 0.39 times 10 to the third. And then again, to make our answers in proper scientific notation, we have to move and subtract that decimal place so we can get 3.9 times 10 to the second.